Trig 4.3, graphs of the tangent and cotangent functions. These are also periodic functions. Let's remember, and let's put this back up again. Got to learn not to do that. There we go. So we're going to go back to the circle, the bullseye, because I've got to keep practicing this. This is the point 1, 0. This is the point 0, 1. This is the point -1, 0. This is the point 0, -1. For 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. Now, for the tangent, we've got the axis at 0. The tangent is y over x. 0 over 1 is 0. Let me change colors. Do this in a blue. So 0 is 0. For the tangent, if we try to plot these points like we did before, tangent 0, 1 is 0. So we plot that point here. The tangent at pi over 2 is 1 divided by 0. But that's undefined. So when we get over to pi over 2, undefined means there's a vertical asymptote. What happens between that? Let's also look sort of backwards here. At a negative pi over 2, which is the same as 3 pi over 2, it's also -1 over 0, another vertical asymptote. We can never allow that division by 0. So we're not given a whole lot of information after this 0, 0 point. If we look at halfway between pi over 4, that's right here. Pi over 4 is the square root of 2 over 2, which is really about 0.7. If this is 1, it's someplace here. A little bit further on, pi over 3 is square root of 3 over 2, which is closer to 0.8 and stuff. And as we approach this pi over 2, we can see that this line approaches that vertical asymptote. Let's look at negative pi over 4. Well, the tangent is now negative instead of positive. So it's some place right here. And a negative pi over 3. That's the negative 0.8. So the tangent, the important part of the tangent, does sort of what we might have learned if you learned what the cubic does. Y equals x cubed. Looks sort of like that. Once you get past the pi over 2, then you start this over again. It starts down here and goes up until it hits the next asymptote. Before that, it started down and goes up. There's an asymptote to the left. Let's take a look at our calculator for that. Now your TI-84 calculator is a lot nicer than this one for graphing these things. First of all, let's get rid of, look at all that, isn't that beautiful? Get rid of the plot and get rid of our two equations. and just look at the tangent of x. We can do this zoom trig. On this old TI-83, this vertical line is not supposed to be drawn. It's not part of the graph. You can think of it as this vertical asymptote, but it's really not supposed to be there. What it is the mode that we're in is connected. And you might say, well, let's just make a dot mode then. Well, dot mode is almost worse. If we graph that on the TI-83, then these get so spread apart because you're approaching that. But that's a little more of what you need to think of it like. On your TI-84s, they've taken care of that stuff. So I'm going to put this mode back to connected. And just think of those as vertical asymptotes. But notice how it repeats and repeats and repeats and repeats and repeats. The only important spot is really this middle one, the one that I've double drawn here. It goes from a negative pi over 2 to pi over 2. So this is a negative pi over 2 where that vertical asymptote is. This is a positive pi over 2 where that vertical asymptote. In fact, there's a vertical asymptote at every multiple of pi over 2 when the period for this, because it starts repeating every pi units. Okay, what is the cotangent then? It is similar. Except now, when you have x over y, it's undefined. Let's go back to the other colors. It's undefined at 0 here. And at pi over 2, 0 divided by 1, it is 0. And then at pi, negative 1 divided by 0, another asymptote. Now, what happens between, though? That's what's important. From 0 to pi over 2, as the angle goes from 0 to pi over 2, the value for x goes from 1 down to 0. And the value of y goes from 0 up to 1. So it's really starting up here and going down there. So it is sort of the flip-flop version of this tangent. But remember, these are periodic functions. It keeps on going and keeps on going. But the only one we're really interested in is this 0 to pi. And the period is also pi. So for the sine and cosine, periods are 2 pi for both. The tangent and cotangent, the periods are pi. And this one close to the origin, and this one really all around the origin, is how you graph that. Now, these are going to be a little bit different when you start adding things to them. Suppose you got y equals 1 plus 2 cotangent 3x minus pi over 2. This really looks like the same one we did before, except now it's with a cotangent for the function. What is a? That's 2. That's a vertical stretch. But for a cotangent, you don't need to worry about too much because it goes to infinity anyway. C is equal to 1, so now it's moved up 1, and that will be shown with that center moving up. The function is the cotangent. So, and once again, I like to give a little quick picture. cotangent does something like that. Period for cotangent and the tangent, pi. B is 3, so the new period for this is not pi, it's pi over 3. And D is pi over 2, this time to the right. So it's up and to the right, I guess, again. What I'll ask you to do for all these is just one period. You still use these steps. The first step, move it up 1. Normally, this is centered still on the x-axis. Now it's moved up 1. This stretch is not going to be really noticeable unless you compare it with something, because all you're doing is stretching an infinitely long piece which doesn't stretch too far. 3D is pi over to the right. Normally, this, I guess I would say, the function starts at the y-axis where there's a vertical asymptote. But now we're moving it pi over 2 to the right, and that's where your vertical asymptote is. For the cotangent, it used to be right on the y-axis. And 4, you used to end pi units later after the pi over 2. Now you end pi over 3 units later. So this is pi over 2 plus pi over 3. You can add that up if you want to. But here's your center. Remember, the cotangent starts up and ends down. So this is done almost exactly like the sine and cosine. It's just that that step 2 doesn't really make a difference. It's hard to see that. Let's check this with our calculator. So we're going to clear out this thing. It is 1 plus 2. Now, we can't say cotangent because it's not on our calculator. But we know we can say this is over the tangent. It's like 1 over the tangent times 2, or 2 over tangent. 3 left paren x minus pi over 2. Close, close. So this 2 over tangent is that 2 times cotangent. 3x minus pi over 2. What is the window? Well, let's see here. The x min is the left side at pi over 2. The x max is the right side, which is pi over 2 plus pi over 3. You can even put it in that way. Pi over 2 plus pi over 3. Scale, I don't know, I would say, since this is going to have a common denominator of 6, I would say pi over 6. Don't know what's going to be best. Doesn't matter for the graph. Now, for these minimums and maximums for the y, you don't need to go too far, I guess. This is moved up 1 unit. So if we go down 4, that'd be okay. But if we go up really 5 units, because this is 1 unit here, we need to go up to 6 to sort of make this thing equal out. And then you graph it. You should start up here. And this is why it's above that 1 right here. That's where 1 is right here. It's stretched a bit. If we wanted to compare that to a cotangent that's not stretched, we could. But you really can't tell what's going on exactly for the stretching and compressing vertically. This horizontal is because we start and end at different places. So what about the tangent? So this is now the tangent. What is A? It's still 2. Vertical stretch. We won't notice that. What is C? It is 1. It still moves it up 1. The function is tangent, which looks sort of like this. Starts down, ends up. Period for the tangent is pi. B is 3, so the new period is pi over 3. And D is pi over 2, but I've thrown in a little curve here because it's plus. This is going to be left instead of right. So it's up and to the left this time. Here's the x-axis and the y-axis. Let's choose a different color again. So we still start. Step 1. Normally the middle of the tangent is still this x-axis, but we are up 1. This stretch is not going to be seen. We'll try to stretch it a little bit when we draw it. Down to D. It's going to work pi over 2 to the left. But this is the one function where we have to do things a little differently. We're not moving the left and right sides of this function. We are moving the center. And then we'll spread out from there. So, normally the center is right here on the y-axis. Its center is now pi over 2 to the left. Negative pi over 2. So now that's where you have the center. And I probably shouldn't have put that dashed line in there, because that really means that we've got an asymptote there. It's the center. Okay. So, up to the left. But that's moved the center, not the asymptote. And now we use this pi over 3. From the center, for the left to the right, has to be pi over 3 units. But that means that each way, I've got to go pi over 6 units. So this is over here, and this is over here. Well, this point is pi over 2. If we take pi over 2, negative pi over 2, and subtract pi over 6, we'll get to this one. If we take a negative pi over 2 and add pi over 6, we'll get to this spot. And the tangent starts down and ends up, stretched a little because of this 2. Let's see how that looks on our calculator. So we've got y equals, now this is almost the same, 2, but it's no longer divided by, it's times, tangent 3x, and it's not minus, but plus. And that'll change this into what we have. But the window is important. We want to go over here to a negative pi over 2 plus pi over 6. Oh, did I do that wrong? Oh my gosh. This is the minus pi over 6, and that's the plus. So this is a minus pi over 6, because we're pi over 6 more to the left. This is the plus. You guys probably caught that, didn't you? Okay, anyway, back to our calculator. So x min is a negative pi over 2 minus pi over 6. That should be a bigger number than the x max, which is a negative pi over 2. Oops, negative. Let's clear this out. Negative pi over 2 plus pi over 6. Oh man. Let's try this again. I'm not looking at what I'm doing. A negative pi over 2 plus pi over 6. Okay, now I got it. The scale, probably pi over 6s. I don't really know. Doesn't really matter. This could go, I think it's not so bad. If it goes to negative 4, it should go to positive 6. And if we graph it, we can see that we have, this has moved up 1. If you wanted to zoom out, it doesn't show that vertical line, but you won't see those vertical lines on yours at all. If you want to zoom out to see what this looks like, number 3, it shows you what we've taken that tangent and done with it. This is the one we're looking at here. So let's do another one. Here's cotangent again. Remember, cotangent will be like the other 4 trig functions. It's only the tangent that's a little bit different. What is A? Negative 1. What does that mean? It gets flipped over. What is C? Negative 2. It's moved down. What is the function? Cotangent, which looks like vertical asymptote right at the y-axis, one over here. Starts up and ends down, except this is going to be flipped. The period normally for the cotangent is pi. V in this case is 1/2. So now the period is inverted multiply 2 pi. And D, this is where you got to be careful. In order for this to be read directly off this, you have to factor out a 1/2. And when you factor it, when you divide by 1/2, you really multiply by 2. So this is pi, because when you multiply that back in, it's got to be a pi over 2. So D is pi, and since you're adding it, it moves it left. So it's now down and to the left. That should be the third quadrant stuff. Okay, let's change colors. Now, step 1, 2 units down. That is the new center. Step 2. Well, it doesn't change, doesn't stretch it, but it does flip it. So don't forget to flip that thing. Step 3, pi to the left. Normally, it's the left side is right here at the y-axis. Now we're going to go pi units to the left and put that asymptote. And 4, it will end 2 pi units later. Well, here's 1 pi, and I guess we're going to be 2 pi units later. This is the negative pi, this is the positive pi. Right in the center is this point. We would have started up and gone down like this, except it's been flipped. So start down and end up. Does that make sense? Okay, another one. A is one that does nothing. No stretch, no squeeze. C, remember the A is right here. If it's not there, it's really just a 1. C is a -3, that moves it down. The function is tangent, which takes vertical asymptotes to the right and the left. Start down, end up. Period, pi, normally. B is 2, so now the period is pi over 2. D, once again, you got to be careful. You got to factor out this 2. Oops, this is an x. And if you factor, you divide, so this is really pi over 2, and subtraction is pi over 2 to the right. So down and to the right, really looking at down and to the right. Well, I won't be able to do this. 3 down. That is our new center. Doesn't do anything for stretching, squeezing. Pi over 2 to the right. Now remember, we're not moving an asymptote here. We're moving the center of the curve. We're moving this point right here. It is moved down 3 and to the right 1. And then from that point, we're going to stretch out to get pi over 2. That means we need pi over 4 to the right and pi over 4 to the left. That's where the asymptotes go. So pi over 2 plus pi over 4. And this one is pi over 2 minus pi over 4. So this one maybe is a little bit easier. This is just pi over 4 because pi over 2 is 2 pi over 4s. And this is 2 pi over 4s and pi over 4, which is 3 pi over 4. A little easier to figure. Down to a -3. Tangents, there's no negative there, so start down, end up. You should be able to do the problems for section 4.3.